Hey everyone, and welcome. Today, we're going to tackle something that honestly sounds like it's straight out of science fiction. Running a massive, professional-grade AI model. You know, the kind that normally needs a whole data center right on your computer at home. So, let's dive into how this is even possible. So here's the big question, right? We've got this AI model that's a whopping 63 gigabytes. But a lot of us, maybe most of us, are working with graphics cards that have, 16 gigs of video memory? Maybe even less. I mean, that seems completely impossible, doesn't it? How on earth can you cram all of that data into a space that's almost 4 times too small?
Well, the solution is actually pretty clever. It's not about forcing it or using some kind of supercomputer. It's about this really elegant combination of two things. First, how the AI is actually built, and second, one single, almost hidden setting that just unlocks the whole thing.
All right, so to really get why the solution is so cool, we first have to wrap our heads around just how big this problem is. We're going to be looking at a specific model called GPT-OS120B, and believe me, this thing is a beast.
This AI has 117 billion parameters. Now, you can think of parameters as all the little individual knobs and dials the AI uses to think and make connections. Just to give you some perspective, some of the famous earlier models had less than 2 billion. So yeah, 117 billion is just a mind-boggling number. It's what gives this model so much power.
And all those billions of parameters, they take up a ton of space. To run this thing the way it was designed to run, you'd need a GPU with about 80 gigabytes of VRAM. That is way, way beyond what any of us have at home. This is usually where the story ends, right? It's a hardware wall you just can't climb. Or so you'd think. So, how in the world is this possible? The secret, it turns out, starts deep inside the AI's own architecture. See, this model isn't just one giant brain. It's designed to be way, way smarter than that.
It uses something called a mixture of experts architecture, or MO for short. Okay, the best way to wrap your head around this is to picture a library with 128 different librarians. Each one is a world-class expert, but only on one specific topic. Now, when you come in and ask a question, you don't talk to all 128 of them at once. The system is smart. It figures out which 4 librarians are the most relevant to your question and sends you to them. The other 124, they just sit back and wait. That, in a nutshell, is Mo.
And that is the magic of the MOE architecture. A normal or dense model has to fire up all 117 billion of its parameters for every single thought it has. But our MOE model, even though it has all that same knowledge, it only needs to wake up about 5.1 billion parameters at a time. Just those 4 experts it needs for that one job. The amount of work it has to do just absolutely plummets.
Okay, so we've got this super efficient architecture. But that still leaves the question, where do you put all those other inactive experts while you're not using them? And that brings us to the next piece of the puzzle, a very clever memory management trick called CPU offloading.
The idea here is actually really simple, but it's super powerful. Think of your GPU's fast VRAM as a small desk. It's right there, and you can grab things off it instantly. Your computer's main system RAM is like a giant library bookshelf. It's way bigger, but it takes a little longer to walk over and get a book. CPU offloading is just the process of keeping only the books you're reading right now on your desk, and putting everything else back on the big shelf until you need it.
So let me walk you through how this whole bookshelf thing works in the real world. When you start to load the model, your GPU's fast memory, that little desk, starts filling up. The system then automatically sees all those expert librarians that aren't needed right now, and it moves them over to your computer's main RAM, the big bookshelf. Then, as the AI is thinking, it only pulls the 4 active experts it needs onto the fast VRAM. As soon as they're done, whoosh, they get swapped back out. It's this constant, seamless shuffling that keeps you from ever seeing that dreaded out-of-memory error.
Okay, this all sounds fantastic in theory, right? But how do you actually do this? How does a regular person make this work without needing a degree in computer engineering? And this is where it gets really, really cool. As YouTuber Louis Decodes pointed out, this incredibly powerful technique has just been quietly added to the tools we already use. It's been hiding in plain sight. And there it is. If you use a program called LM Studio, it's just a single checkbox. That's it. Force model expert weights onto CPU. You tick that little box, and you're telling the program to do all that clever shuffling between your fast VRAM and your main RAM that we just talked about. I mean, all that complex stuff, it all comes down to a single click. It's wild. Just look at this. This chart really drives the point home. You are actually successfully running a 63-gigabyte model with only 16 gigs of graphics memory. You're not just bending the rules of what your hardware can do, you are shattering them.
Okay, I know this sounds like some kind of magic trick, but in the world of computers, there's really no such thing as a free lunch. Being able to do this, to get this incredible access, comes with a trade-off, and it's a really important one to understand. Right, so the upside is huge. You can run these state-of-the-art AI models on your home computer, no more memory errors. The downside? Well, it's speed. That whole process of swapping the experts back and forth between the slow RAM and the fast VRAM, that takes a little bit of time. It's not going to be as blazing fast as a giant enterprise GPU, but the amazing part is, it runs.
So what does that speed trade-off actually feel like in practice? Well, you get a speed of around 15 tokens per second. To put that in perspective, that's roughly as fast as someone typing really quickly. It's more than fast enough to have a conversation, to code, or to do some creative writing. It's not data center fast, but it is incredibly usable. Look, the real game changer here isn't about raw speed, it's about access.
And you know, just getting the model to run is really only the beginning. Now you get to play with the same controls the pros use. You can tweak things like temperature to make the AI more creative, or repeat penalty to keep it from getting stuck in a loop. You can basically fine-tune its personality. The power to tweak and experiment is literally in your hands now.
So what does this all boil down to? It means the barrier to entry for using seriously powerful AI has just been completely demolished. And when you give this kind of power to millions of creators and developers and curious people all around the world, the real question isn't if something incredible will be built, it's what will it be. Thanks for tuning in to This Explainer.